Hi, I'm Bob Vila. Welcome to our storm-ready house here in Punta Gorda, Florida. The house is coming together very nicely. Today, we're going to be showing you a decorative staining system for a concrete slab. We're also looking at the soffit system being installed. That's a real important part of hurricane readiness. And we'll be putting in a heat pump and some very special ductwork. Stick around. Last week we were installing our beautiful porcelanosa tiles, these oversized porcelain tiles that are designed to look like kind of steel plates, actually. And it's quite a dramatic effect in a Florida house. It's also very soothing because when you have a lot of light colors, remember they're reflective and they make it hotter sometimes. And Jim and Teresa are here this morning. Hi, how are you?
Hi, Bob.
Our homeowners.
Hi, Bob.
It's great to see you. You must be getting very excited at this point in life.
Yes, extremely excited.
Yeah, we're about 3 to 4 weeks away from letting you move in. And you've been living in a trailer in what town?
Arcadia.
Arcadia, Florida, which is just east of here.
It's about 15 miles east of where we are now.
Yeah. All right, so have you gotten used to trailer life?
No,
No.
I don't think we can ever get used to trailer life.
Yeah.
It sits in the middle of a swamp in the sun. It's really hot.
And you're just a handful of the many victims of Hurricane
Yes.
Charlie who are still living under
Yes.
those conditions. And you're lucky your 2 dogs are being kept over here, right? So that you
Right.
don't have to worry about the
Yeah, the gators are plentiful.
gators
And
are
they like
plentiful
dog.
on the Peace River, and they love dog. Yeah. But your friend Tom is here helping you out with this finish, right?
Yes, he
Hi,
is.
this is Tom Moorad. And you're all going to participate in putting down this finish on the concrete slab?
Yes, yep, we're going to...
So, Tom, what is involved in doing this?
Well, you need to first etch the concrete with a mineral acid to allow the absorption and...
So a mineral acid, not like a muriatic acid?
Right, right, because we're using acrylics. And the muriatic acid's much too strong and it keeps activating the liquid in the acrylic.
I see. So you've washed it with a mineral acid.
That's correct.
And if I want to
We
do
refer
this
to
at
that term as
myself,
shocking the substrate.
Shocking
into
the substrate.
Absorbing the stain.
the substrate being our
The
concrete
substrate being
slab.
the floor.
And the problem with a concrete slab that's just unfinished like this is that it's always kind of dusty. And if you spill something on it, sometimes the stains won't come out.
That's right. After it's etched, it will look chalky, but it should not feel chalky.
All
There
right.
should be no residue on the surface.
This has been etched, and now how do you do it? I mean, do you
Well, I apply the stain with just these hand pump
go ahead and show us?
applicators, and I try to make drift patterns.
Now, you've used a brown stain in here, right?
That's correct.
But do I assume you can go with any color you want?
Oh, yeah.
Red, green, yellow, or in between?
Hundreds of colors available.
And then this is kind of like a little skimmer,
Right.
squeegee.
To help move the material. You don't want a lot of pooling.
Yeah, you don't want any puddles forming.
Right. So you want to be able to move it around. Be sure it absorbs in for a long-lasting job. That's pretty much the activity.
And then what's the timing? Does it need to dry overnight, or?
It dries very fast.
So once you've dried it, is that all there is, or is there another coat that you add later?
Well, there's going to be 2 more colors because we're making an attempt to tie in these colors with the porcelanosa tile.
Okay.
And so there'll be 2 more colors applied and then a clear coat of gloss sealer.
So tying it in with the porcelanosa tile, does that mean you're going to make it darker?
That's right, yeah.
I see.
Yeah.
Okay. And then what color did you choose for the pool deck?
Oyster.
Oyster.
Just a nice light because of the heat that will be out in the sun all day. So they...
Yeah, out in the sun you do want to reflect the heat as opposed to absorbing it.
Right,
Yeah.
right.
And then what are you doing? The bedroom's going to have a wood floor, right?
Right, a Bella wood, hardwood, Brazilian walnut.
Brazilian walnut. Okay, so you've made some interesting choices. All right, Tom, we'll come back later in the show to see how you're doing.
Great.
Thanks. All right, let's recap a couple of the features of our storm-ready house, like this door. front door that swings out instead of in. That means it really has a stop behind it, and high winds will not blow it in. That's just a primer color. It's going to be painted dark like the colors of the windows over here. The other thing is the impact-resistant glass that we have throughout the house. And then, of course, the fact that all of our exterior walls are solid structural walls. They're poured concrete. Leslie Chapman-Henderson is with us again from Flash.
Hi, Bob.
How are you?
Very well, thanks.
Now, we are building this house so that it can withstand really bad storms. And one of the last structural systems that hasn't been completed is the roof overhang, the soffit detail, as it's referred to.
That's right, and we've really beefed up the framing here because the codes are largely silent on soffits. So we've seen a lot of failures in high wind events, and when you get failure, the wind pushes up and the wind-driven rain follows right behind it. In the immediate aftermath, mold develops and all types of problems ensue.
Your insulation gets wet, your ceilings collapse, and it's a nightmare. Although I think there are two schools of thought right now about whether you have venting or no venting at all. Some people like the idea of a totally enclosed attic system.
That's right. A lively debate is underway, and I don't think we have all the answers there yet. But in the spirit of finding the right answers, that debate will continue.
Yeah, well, the debates have taken place over all the different elements. All of this beautiful red tile that's up there used to be put on the roof with just a patty of cement, and now we have two mechanical devices, screws, that fasten it to the plywood. But anyway,
right.
Getting back to the soffit, is it aluminum?
This is vinyl, and this is Joe Brees from Alcoa.
Hi, Joe. How are you?
Hi, Bob.
So vinyl is final, but it's also pretty flexible. Isn't that a problem when you're talking about high winds? And what about wind-driven rain getting into the soffit?
Well, normally when people think about soffit, they think of aluminum soffit. And what we found is that vinyl soffit actually has a lot of advantages over aluminum soffit. One of them being that it has this locking system on it. So when a wind load...
This locking system.
This locking system
Where
along
from
here.
one panel to the next, they
Exactly.
kind of come in and they lock together. Like that. Yeah, I hear you.
So what occurs when a wind load or any kind of load is placed upon this panel, it actually forces itself together and pulls itself together, a lot like two hands gripping together.
Okay, so that's the thought. And how is it actually applied up there? How is it attached to our soffit frame and to the house?
We see what Larry's doing right now is he's placed a J channel on the wall, which he...
That's basically this material here.
Yes, exactly.
Yeah. How's he attach that to
And
the
he's
wall?
attaching that with these 5/8 stub nails. And he's doing that about every 16 inches along the wall.
All right. And then
now-
he's cutting them to shape.
Now he's cutting it to shape.
And of course he's got a corner here, so he's starting off with a 45-degree. Staples.
Now, one thing you'll notice about this soffit is that you really can't see any type of ventilation on the surface of it. Typically, soffit has pinholes in it or some kind of lancings that allow the air to flow into it. What we've done with this panel is we've actually hidden that ventilation up inside the grooves, and it gives it a real nice aesthetic, but at the same time, this panel actually has about 80% more ventilation than any kind of standard vinyl panel you'll find out there.
All right, well, thank you, Joe and Leslie. Great to see you. I'm going to go out back
Thanks,
and
Bob.
find Todd Davison from FEMA and ask him a few questions. Hey, Todd, how are you?
Bob, pleasure.
Now, we've talked a lot about Hurricane Charlie here in Punta Gorda, but Florida had 4 major storms last year, and one of them is called Ivan. Tell us about Ivan's damage.
Well, Hurricane Ivan, of course, was a very large storm, very slow-moving, and had tremendous storm surge for the entire panhandle of Florida and coast of Alabama.
Is the larger the diameter of the hurricane indicative of a higher storm surge in the
It
waters?
is in the forward speed of the storm.
Yeah.
Contrasted to Charlie here, which was an intense, very small, very fast-moving storm. Didn't have time to build up the storm surge, but conceivably you could get the exact same kind of storm surge
Right.
here
Yeah.
in Charlotte County.
What kind of damage did you see up in the panhandle?
Tremendous. 15,000 destroyed houses, another 25,000 uninhabitable. Lots of flood damage, serious flood damage.
But even elevated bridges were raised off their bases, right?
Yeah, the loading from those waves, of course, is just tremendous forces, and there are practices, of course, with houses to prevent that damage,
Yeah.
as we'll see today.
Now, FEMA helps to set guidelines in terms of how we rebuild.
That's correct.
And one of the key things has to do these storm surges, the flooding gets in under the concrete slabs of the homes, undermines them, and thus destroys them.
Right. So the idea is really the vertical risk, and so the requirements for local governments to build to is simply to raise the floor of the building above the projected flood heights.
Right, so if you're in an older home, you might be, I think the projected flood height here is what, 9.5 feet?
9 feet even.
If you're in an older home, you're kind of grandfathered in, right?
That's correct.
What does that mean from the point of view of floodplain insurance?
Well, from an insurance standpoint, the older homes that were built in the 40s, 50s, 60s are not risk rated. We give a flat rate. So a house that was built in the 70s would carry, for this side, about a $900 premium.
Wow.
The house behind us, of course, is elevated to that elevation plus another foot of freeboard or safety factor. And so that home, as an example, would have about a $400 premium. So there's significant savings associated.
Exactly. When you're building to code, you're going to save half the annual insurance. And here, actually, our floor is at 9.5 feet, including the outside deck and the deck where we have the air conditioning and everything else. So that means that we're going to have A, a better chance of surviving those floods, and B, a lower insurance premium.
Absolutely. The idea is when you get that storm like Ivan, but back in the Charlotte County area, that the water will come up and will go down and won't get inside the house.
Thanks, Todd. You'd never know that beautiful canal could turn into a monster.
Much different scene.
Yeah. Okay, I'm going to interrupt Bill Zoeller and Lance Keeling, and both of you guys are going to inform us a lot about how we've made this house energy efficient. You're with the architecture firm that consults to Mercedes Homes.
That's correct.
And we have a little bit of bragging rights here, because this house is going to be a lot more energy efficient than the average Florida home, right?
Well, that's right, Bob. The way we've done our analysis, this house will be about 50% more energy efficient than the typical house built in Florida today for the same amount of square footage. What we've been able to do was take all the energy uses that typically go into a house and attack them one at a time to come up with the best combination of specifications to get that overall energy use as low as possible.
Now, tell me, what are some of those specifications?
Well, the first thing we did was specify the low E windows. Low E means low emissivity.
Right.
And basically what the low E windows do is they let the light in that your eye can see from the solar energy side, but they block the solar energy that's not visible light. So,
Which is what causes heat gain.
Which is what causes heat gain, correct. The windows that we've got here are actually very good. They have a very low, what's called solar heat gain coefficient of 0.3, which means it blocks about 70% of the solar energy that we want to block from getting into the house.
Great. And now all our walls are solid concrete. Do we have to add insulation to something like that?
Yes, you do. What we've done here is we added 1 inch of polyiso cyanurate insulation boards that adhere directly to the concrete. The concrete is 6 inches thick, gives us a thermal mass capacity on the outside, so they heat up slowly during the day. That polyiso insulation, which has the highest R value per inch of any insulation on the market, is enough to stop that heat flow from getting into the house, and also makes for a very airtight package.
What are some of the other little measures that we've taken?
Well, some of the more simple things we've done, we've used Energy Star appliances.
Right.
We've got a very high SEER air conditioning equipment. But we've also got something that's pretty unique here with the air conditioning ducts themselves. Typically in Florida, the air conditioning ducts are simply suspended in the attic where they're subjected to maybe 140 degrees, 150 degrees of air temperature.
On all four sides.
On all four sides while you're trying to blow 50 or 55 degree air through them. What we've done here is we've taken those ducts, dropped them on the attic floor, and then just buried them with insulation. This is a process that we actually pioneered out in California that is now part of the California Energy Code, that several thousands of houses have been built using this technology. We had to do one thing different here, however, because it's a hot, humid climate versus the dry climate in California.
Right.
To prevent condensation from occurring on the ducts, just like a glass of iced tea in the summer gets all drippy.
Right.
To prevent that, we went and put a closed-cell polyurethane foam around those ducts to prevent the moisture from reaching the dew point on the duct surface,
Gotcha.
allowing us to bury the ducts in the insulation, and coming up with a very high R value for the ducts and some additional duct tightness.
And Lance, this isn't just any old insulation, right?
That's correct,
It's kind
Bob.
of taking green to the extreme. Tell us about it.
Well, it's a soy-based insulation. What they do on a chemical level is replace the polyol that comes from petroleum with polyols coming from soybean. So even though it starts out as an organic product, once they get to the polyol level, it becomes completely inorganic. So there's no food value for mold or pest or anything of the sort.
That's really important.
Yes.
Okay, now what's the actual process of installing it in our attic? How do you do it?
Well, there's equipment that puts the chemical under pressure and under heat.
And
there's an A side and a B side that comes together, and at the tip of the gun, when they join, it begins to make foam. The foam sets up within 15 to 20 seconds. So you just spray it on the duct, and it just completely encloses the duct system.
Now, what kind of an R value are you getting here?
With this particular system, we're at a 4.8 per inch. So to achieve the 13 or the 7 in addition to the 6 that Bill is going for, we're spraying about 1.5 inches of this foam.
Now, could I get the same results if I was a do-it-yourselfer and I just bought 4x8 sheets of polyisocyanurate and cut them up and put them on my existing ductwork, or is that a mistake?
Yeah, that's a mistake, Bob. What you're really going for here is an air seal. So with this foam, when you spray it on, it goes on like a liquid glue type substance and completely encloses. When it expands, you don't have any place for air to leak through, carrying the humidity, which can condense on your ducts.
That's why it has to be closed cell, right?
That's correct. That's correct. If you use an open cell foam, the moisture can actually migrate through the material, get to the dew point surface, and actually condense within the insulation material itself.
Now, have you guys made any projections of what the energy savings actually amount to? What's it going to cost every month to run this house?
It's going to cost about $100 a month. The overall savings is about 50%, as I mentioned. Our projections annually that this house would cost about $2,400 to run, or a typical house would cost $2,400 to run.
Yeah.
This house would cost $1,200. So it's $100 a month savings.
That is such good news. Now, one other feature that we want to talk about is right outside the garage door. Okay, so this is a Whirlpool heat pump. What's the logic in terms of our choices here?
Well, this is a pretty efficient unit. This is a 14 SEER unit. That's SEER, which means Seasonal Energy Efficiency Ratio.
Okay.
That's about 40% more than the most basic unit on the market.
That means it costs more, right?
It costs a little bit more. Yeah, it costs about $1,200 or $1,500 more when you compare one to the other. But some of the other things that we put into the house, like the better windows, the better duct system, allows us to put a smaller air conditioning system in. So the smaller system actually saves money to pay for some of those other improvements.
So it saves money on an operating basis.
It saves a lot of money on an operating basis.
That's
correct.
great. Terrific. Thank you, Bill. Okay, we're back on the lanai. I want to call it the lanai because it's like a big Hawaiian porch. Tom, this is the final coat, right?
Yes, this is the clear gloss acrylic sealer.
And this takes how long to dry?
Approximately 2 hours.
Okay, so I'm kind of walking on an area that doesn't have it yet.
Right.
But this will, in fact, dry to a nice glossy surface.
Yeah.
Okay. Does this last for several years, or do you have to redo it every season, or what's that like?
In a covered area like this, it should last at least 3 years before you'd have to wash it and redo it.
Yeah. And what about cost? How do you figure the cost of a job like this?
Well, the cost basis is usually based on square foot. It's usually $3 for an exterior and up to $7 for an interior. Interiors are more difficult because you've got all the water and the chemicals indoors.
And you might have to move furniture and stuff.
Yeah, and use a shop vac
Yeah.
and squeegees.
Okay. Well, it looks beautiful. Thanks a lot, Tom. Next time, we're going to be working in the kitchen exclusively, putting in the kitchen cabinets, showing you how you make the templates, installing the Corian countertops, and we're even going to move in some appliances. Till then, I'm Bob Vila.